It's going backwards fast.
On Thanksgiving Day of 2024, I purchased a 1984 Pontiac Fiero with the intention to convert it from an internal combustion engine to fully electric. That winter break, I removed all the gasoline components: engine, gas tank, radiator, and exhaust systems. I left the manual transmission in to simplify the connection between the motor and wheels, but moved to a clutchless design. In order to mate the transmission and motor, I built a custom adapter plate and coupler. I first made a template of the adapter plate from plywood, and test fit it in the car. I then transferred the template to half-inch steel and painted it with anti-rust paint. While the adapter plate holds the motor in place, the coupler mates the motor shaft to the transmission shaft. I machined a round quarter-inch steel disc and bolted it to the modified clutch disc. Using a 3D printed piece to align the two shafts, I then had the motor shaft sleeve welded to the assembly. Once the custom machining was completed, I installed the motor in the car and began on battery installation. I am using 3 modules from a Toyota RAV4 hybrid. Together they amount to 132 volts nominal and 16.5 kilowatt hours. I installed rails from salvaged metal shelving to mount the batteries on. The high voltage wiring is protected by a 450 amp fuse and main shutoff. The power then runs through the main contact and into the controller. When the car is first turned on, power is routed through the pre-charge resistor before the main contact closes. The low voltage system is powered by a DC to DC converter that takes the 132 volts from the main battery pack and converts it to run the 12 volt systems. In addition to the original 12 volt functions in the car, I added a contact for the pre-charge resistor, a delay timer that drives the main contact, and power into the controller. Once all of the wiring had been completed, I was ready to test the functionality of my new electric vehicle. Surprisingly, I had done everything correctly, and the car first spun the wheels and later moved under its own power on January 8, 2026, just over a year after I had begun officially working on the project. Although the car moves, I still have a lot of work to do. When removing the engine, I also removed 3 brake calipers because they were seized up. The car will need new brakes and a vacuum pump to generate sufficient brake boost force for higher speed driving. Additionally, the battery management and charging systems will also need to be installed. With the current state, once the traction batteries run out of charge, there is no way to recharge them. The last major project is reworking the gauge cluster. The tachometer will be repurposed to display amperage draw, fuel level will display battery charge, and oil pressure and temperature gauges will show battery and motor temperatures. Overall, the car moving proves that the prototype can work and shows the result of countless hours of thinking, planning, and implementation.